you can use. So tonight we're gonna have Gary Crawford. He's a senior consultant for ThoughtWorks. Yeah, he's playing with Clojure in day-to-day life and at work and extra. So yeah, this is it. I'm gonna let Gary speak.
Leiningen, you're insane. They're not creatures you can fight. They're an elemental, an act of God. 10 miles wide and 2 miles long. Ants. Nothing but ants. And every single one of them a fiend from hell. Now that quote comes from a short story written by an author called Carol Stevenson, who is a German author, and the story was first translated into English in 1938 for publication in Esquire magazine. And the words that you heard there are of a district commissioner somewhere deep in the heart of the Brazilian rainforest. And he's addressing Leiningen himself, and he's saying, if you and your workers stay in the face of the oncoming mass of army ants, you're going to have the flesh torn from your bones. A very strong sentiment. Now, for us in the Clojure world, the story of Leiningen versus the ants has a very meaningful part in our community. Does anyone here in the audience currently play or work with Clojure? Okay, so a few. Would any of you like to take a guess at what Leiningen means to us here in the community? Leiningen, what's Leiningen for us in the Clojure community?
It's the build and dependency management tool.
Absolutely. It's a build tool, and I absolutely love it as a build tool because it makes our life very, very easy. But I also love the name Leiningen, because if you think where the names come from, Leiningen versus the ants, and if you consider that the pointer to the ants could be Apache ant, then perhaps you could consider that it's about Leiningen versus the ants, Clojure versus Java, functional programming versus object-oriented programming. So perhaps it sums up some of the sentiment that we're feeling and talking about in the community just now. So I'm Gary, I'm a consultant here at ThoughtWorks, and I'm one of the lucky ones who gets to play with Clojure on a daily basis. But before I started here with ThoughtWorks, I worked with a company who focused on management of chronic disease, research systems for the management of chronic disease, and in particular an area called stratified medicine. Now, you can think of stratified medicine as being personalised medicine, essentially looking at the genetic makeup of individuals to determine how best can we treat these chronically ill people. And as you can imagine, it was quite an innovative company, quite a forward-thinking company. And as such, they always made a lot of time available for us to explore different things extracurricularly during our work time on anything really that was innovative, that was applicable to the management of chronic disease. And that's something I always grabbed at with both hands. In particular, I'm a big believer that programmers should read research papers, because it's a great way to know exactly what's happening, how you can keep on top of things. There tends to be a very big gulf between cutting-edge research and what we're actually doing in our day-to-day lives. And I remembered back in 2010 reading a paper that said that Twitter mood was able to predict the stock market. I thought, wow, that's quite impressive. We could do a lot with that. I thought, so how can I make this applicable to what I'm doing during the day? How can I get this into one of our projects on a daily basis and start exploring it? And it turns out I wasn't the first person to think of this. It's actually a very widely researched area. And one of the reasons it's very applicable to the management of chronic disease is chronically ill people tend to be immunocompromised. And what that means is either through the disease itself or through the medication that they're receiving, then they tend to not be able to fight infection in the same way that you or I can. So simple things like flu, which for us would not be nice at all, and we want to avoid at all costs, for people who are chronically ill, could potentially be fatal. I'm just going to jump ahead a couple of slides because I've suddenly realised I have a pointer back to the GitHub page for Lineagen. So if anybody wants to know more about Lineagen versus Yance, the quote's actually at the top of the GitHub page there. So back on the management of chronic disease, we started trying to replicate some of the research that we've found about predicting the spread of contagious disease, such as flu, using Twitter. And what we found quite quickly was that the data science behind it wasn't particularly difficult. Now, I will caveat that I was working with data scientists. I'm not a data scientist. However, that said, even I could get my head around the science that was going on behind the numbers. What was much more difficult was coming up with an architecture that was able to do this analysis in a way that was fast enough and able to stream back to the end users in a way that was meaningful. And this surprised us because we were in an environment where we're working with big data technologies on a daily basis. We're working with Hadoop, we're working with a lot of NoSQL technologies, we had some massive clusters that we're working with, but still we couldn't quite get our head around how can we handle streaming data and extract sentiment and give feedback as to whether or not chronic disease is prevalent and spreading. So at the start of this year, when ThoughtWorks told me I was going to join what's now lovingly known as the Clojure team, one of our projects, I decided to come back to looking at sentiment analysis as a means really to play with Clojure and get up to speed with what I needed to know for the project. But in addition to that, you're probably well aware that in Scotland in September we've got a very big decision about whether or not we should remain part of the UK or whether we should be an independent country. And it's a decision that I think a lot of people are finding very difficult to make and find further information about because it's difficult to get unspun, unbiased information from the media. So the other motivation for me was to see if I could start to track sentiment analysis, use sentiment analysis to track sentiment around the referendum. Now, to be fair, at the moment, I'm not that much further forward in the referendum. However, what I have come up with is a bit of an architecture that allows us to do some of these things in real time in a much more scalable way. And that's what I'd like to share with you today. So, at the top level, it's very, very simple. There's not many moving parts in here at all. And what we're really interested in today is this business logic section down here. I'll give a brief introduction on the other areas at the top, but this is really the focus. This is what's providing the analysis for us. So before we can do any kind of analysis of social data, we need to get it. And of course, for this, in the case of Twitter, we need to hook up to the Twitter data. There's a few ways that you can get data from Twitter, for example, the REST API being one of them. But it's not really fast enough. We need a much bigger flow of data coming into us. So we hook up to the Twitter streaming API for this. Now that process of hooking up in itself is doing some filtering. We're certainly in the area of looking at the referendum, we want to say we're only interested in English tweets. We're only interested in tweets within the UK. But it's very difficult to say that you only want the UK. You can give Twitter a bounding box, but the unusual shape of the UK makes it very difficult to narrow that filter down. So essentially we say, give us all English tweets within a massive area that covers pretty much more than Europe. And after that we do the further filtering at application level. The one other criteria that we give it for the filter is that we want geotagged data. So this is data that's coming from devices that are geo-enabled, so they're providing location information. Unfortunately, in some cases, when that type of information is not available, it can fall back on where your account's located to, but that's okay. So we have data coming in, and we have massive volumes of that data coming in. And a healthy practice is, rather to try and process that data straight away, is to buffer it in some way, so that if it's going faster than us or it's starting to back up in any way, we've got a buffer so that we allow ourselves the opportunity to catch up. Now, for this, we're using LMAX disruptor. Now, I'm not going to go into the detail of LMAX disruptor. If anybody's never heard of it, it's definitely worth researching. LMAX, the guys at LMAX essentially were coming up with a transactional system that had to process millions of transactions per second. And they found that the best way for them to do this was not to split the logic out and do it in parallel, as you might expect, but actually to have it running in a single thread, and to pay careful attention to mechanical sympathy. So things like locks and contention and so on, eliminating that from the architecture altogether, and in doing so, they can get a much, much higher throughput through the system. So I guess we're rich. Mario Morales, a few years ago, famously said that data is a new currency. So we're hooking up to a massive flow of data, we're buffering that data, it's growing and growing and growing, so perhaps we're rich. Well, probably not. The reality is that data at its earliest stage isn't actually worth that much. And Mr. Morales actually went on to say that the companies who are understanding this are building ways to analyze that data and extract that information. Data in its raw form, and I use raw in inverted commas, isn't very valuable at all. The reason I used the dreaded air quotes around raw form is data sets in themselves, raw data is an oxymoron. It can't exist. By the very fact of the data being included or excluded from that data set, we're essentially saying we're pre-processing it. For example, context is very valuable when you're looking at sentiment analysis. Going back to the quote with the district commissioner, different ways, different tones it uses in his voice, different ways that he says things could very much affect the real meaning, the true meaning of what the words actually mean. So we don't have raw data, but because we're going to be doing data crunching on this at volume, we can make our peace with that. And the thing really that we're interested in here is a conversion of this initial stage data into analytically prepared data. We want to specifically say what sentiment was displayed, we want to say where was it sent from, and we want to ask when was it sent. And those three pieces of information are actually very, very powerful. So now to start looking at the core of the logic. So the data's come in through Twitter, it's been buffered into LMAX, and it's now been dispatched to a single threaded business logic. So it's going to follow through each of the stages in here. So first of all, we want to ask ourselves, what sentiment was displayed within that text? Now, there's many different ways of doing this. There's machine learning techniques, there's text-based techniques. And we're not actually doing anything tricky here. We're doing something built on top of what was originally called PANIS. PANIS is a small questionnaire, this is it, no more than this, where you rate how you feel in that current moment on a scale of 1 to 5. And once you have the scores for those different sentiments that you may be feeling, or different emotions you may be feeling, you can then combine the answers to those to give you positive effect and negative effect. Essentially, how happy are you feeling or negative are you feeling? This was later extended to PANIS X. I believe there was around 60 or so terms that were included in that. And in doing that, you're able to start extracting much more information about other affective states, shyness, fatigue, serenity. You can look at fear, hostility. So it's much more granular. But nonetheless, in its raw form, we're still asking people one-to-one questions. More recently, PANIS-T came out in a research paper, and PANIS-T is essentially PANIS X, which is changed to fit online social networks. So we're still measuring positive and negative effect. We've got 11 different specific effects we can get. We know that PANIS was originally used in clinical research and business context. It's widely used and it's widely validated. And one of the really interesting things with PANIS-T is it accounts for bias in certain sentiments online. So we know that people who are on Twitter will tend to be tweeting about things quite happily. I'm very jovial today, and that tends to have a much bigger bias. Similarly, things like negativity or shyness and things like that tend to be a little bit less. Now, you'll probably have picked up on the fact that this is all based on text. This is all based on people answering questions. And we need to be able to take the text that's coming in from an online social network that doesn't have somebody answering specific questions and get it into a format that we're able to actually extract that sentiment from. So there is a sanitization step that we have to do. Essentially, we want to exclude all media, advertising, and spam. So a lot of things that include URLs would immediately be removed. Now, some would argue that perhaps that's extracting some sentiment itself. If I feel really passionately about something, I might retweet that URL. It doesn't mean I should necessarily be excluded, but we can't handle all scenarios here. Like I say, this is more about the framework than the data science. We need a stage of lemmatization or possibly stemming. Lemmatization, which is the approach that we've taken the system that we're building, essentially looks at a dictionary and compares the words, figures out what they are, and comes back to a root word that actually has knowledge about what that word means. So there could be many different variations of things that could be said and different interpretations of it, but if we can come back to a core root and then compare that to the words that we're looking for, then it becomes much easier, we get much more success. Another thing we need to do is part-of-speech tagging, because I could have the word jovial in a tweet as many times as I want, but if it's prefixed with not, or even not is a few words away, then that's a concern that can completely turn the meaning of that phrase on its head. The important part here isn't so much about Panis T or what it's doing, but the important part is what comes out of this stage is a key. So each tweet comes out saying it represents fear, hostility, shyness, attentiveness, with a keyword that describes that tweet. Now, to be fair, a tweet may have more than one sentiment, but the research paper that this part was initially based on says that it always takes the first matching word and bases the sentiment on that. That could probably be improved upon.
Is it literally taking the word and mapping a word to a sentence?
It is post-lemmatization. So, yeah, you might not include a specific word, but the lemmatization process might get us to there. But yeah, it's literally matching the word. And it takes into account different variations. For example, run, running, runner, and so on would be shortened down in such a way that it can match on that. So the next step, once we've got the keys for the sentiment, we move on to where. A very difficult question. And the answer is actually really quite simple. It's a map. Now, one of the limitations of big data environments like Hadoop or working with LMAX Disruptor is you have to be very careful about external dependencies. For example, if you have even a small Hadoop cluster, and in each of your mappers you're hitting out to a geolocation service somewhere on Bing or Yahoo or Google, very quickly, with not that much data, you could end up causing a denial of service. Not to mention you're taking on board all the latency and all the kind of the things that you can argue about, the things that you can reason about within your application. You don't want to be doing that. So one of the things I had to address was, how can we figure out the location that this tweet has been sent from based on longitude and latitude without taking an external dependency, without having to manage a heavyweight local database? Now, have any of you heard of D3? You know it as perhaps a visualization library? In this case, we're actually using it as an analysis tool. So what we've done is, rather than run it in the browser down on a client, we're using the Java FX8 web view, along with the new Nashorn engine that's been released with it, to move D3 to the server. So we're essentially creating a page that has a pile of JavaScript loaded within that page. The JavaScript simply has some helper functions on it that says decode, for example, and takes a couple of parameters, longitude and latitude. And what the D3 does is it takes in a pile of topo.json, creates this map in memory, so this is all running in process with the application, and then we're able to pass in the coordinates and get them back out without actually binding to a DOM in any way and without visiting the client. This is all running server side. Turns out it was actually really quite fast. One of the things to remember with this, though, is a lot of the time, almost all the time, we'd be running in a headless environment. So how does that work with a graphics context? Well, in our case, we're using XVFB. It's actually Max Edwards, another thought worker, who he used Vagrant to create a dev environment for us that's entirely headless. So everything that we're doing is based on Vim and Fireplace and some of the popular Vim plugins for Clojure, running entirely in a headless environment, and we're able to run D3 server-side in order to do a lookup on coordinates. So all we simply say is, here's a coordinate, what colour are you? We go to the coordinate, comes out as blue, you're in Scotland. Really fast, really easy. Same with England, Wales, Ireland, Northern Ireland, absolutely all works fine. It's really, really fast. So what we aim to come out of that step with, again, is a set of keys. SCT for Scotland, ENG for England, and so on. The next big question is when. When was this tweet sent? Now, we're lucky that the tweets that come in do have timing information within them, but we're not actually interested in the very, very split second or microsecond that that tweet was sent. What we're interested in is grouping it to within a time frame. So, for example, if a tweet came in just now, 14 minutes past 7, I would actually group that under a few different time zones. So that would be 40 minutes past 7, and forget about the seconds. It would also come under 7 o'clock. It would also come under today. It would also come under this month, and it would also come under this year. So every single tweet that comes in for a single time actually gets categorized across 5 different time frames. And again, we use them as keys. So now we have a pile of keys which represents sentiment. We have a pile of keys which represents location. And we have a pile of keys which represents when and time that was sent. Now, once we have that information, we're in a position where we can start doing the analytics. Now, when I initially mentioned LMAX, one of the things I glossed over the top of is LMAX uses an event sourcing model. So everything's running in memory, so it's super, super fast. I've actually taken a little bit of license the way I'm doing this because I know for a fact that LMAX can go considerably faster than my logic in here can. So I've not been too worried about exactly how I access that model. What I've done is I've taken the key value store Redis. It runs entirely in memory, fits absolutely everything in memory, so it's super fast, and it works purely in a key value pair function. But this initially is where I ran into the same issue that I had when I started looking at this for tracking chronic disease. We tend to group things by itself. We tend to group things together. So for example, if I have a global ID that is tweet ID 1, so tweets come in, I increment that global ID and I get a number back. So we say that tweet is ID 1, in the same way as you give anything a database an ID. A common way to work in Redis is to say tweet 1 has a location of ENG. Tweet 1 has a sentiment of jovial. It's grouping everything together again by that single object. And after a while of thinking about this, I started to realize that really we didn't want to group by the object. We wanted to group by the thing that we're analyzing. For example, if you imagine the left-hand side here being the key that we store things in, with the key value store, the right-hand side is essentially a string. What we can do with that string is when the first tweet comes in, we can say, where were you? Go to our map, look it up. Oh, yep, you're in England, fantastic. We can increment a bit in the England column and leave everything else as 0. When the next tweet comes in is Scotland, we do the same. Next one comes in, back to England again. And you can see the way this trend starts to go. So for example, this represents 16 different tweets coming in, each one incremented against the country that it has. Now, the benefit of that is you can quite easily see from the color coding exactly how many notch up against each of the locations, against each of the keys. And Redis has some built-in support for this kind of thing. Redis has fantastic support for bitmaps, so you can store a key and a string value and gradually increase the size of that string by adding incremental 1 digits to the value that you're storing. And the computer can count that massively fast, really, really fast. So the output is 8 in England, 4 in Scotland, 3 in Wales, 1 in Northern Ireland. Fine, not bad, fair enough. Another example, jovial, shy, hostile, fatigue. So a subset of the overall sentiments we want to gather. 1 in jovial, one in hostile, one in shy. Again, you can see the way this is going. There's the totals. What happens when we ask a question though? And this is where it starts to get interesting. This is where we start to get the speed. For example, how many people in England are happy? Well, we can pull in our key value for England and the string that represents all of the counts. We can do the exact same with jovial. We can do a very simple AND operation on that. And I think you can probably see already where this is going. We can very quickly count who comes into both the England and the jovial categories. We'll take another example, a slightly trickier one. How many people in Scotland are tired and grumpy? So firstly, we look at our hostile category. Secondly, we look at our fatigue category. We do an OR operation on this. So we're looking for anyone that is hostile and fatigued. So we have a value that represents both of those. We can then bring that in against our Scotland count, do the AND operation on there, and we very quickly get a count of 2. And you might think, 2's not too bad, you're not as grumpy as we thought, but considering there was only 4 tweets from Scotland, that's 50%. So maybe we are quite grumpy after all. Okay.
Sorry, can I ask?
Yes.
So once you've got X million tweets in, are you doing that adding on strings of several million bits? Or?
Yeah. So those strings do get very, very big. However, you can break those strings, so you don't need to contain them within a single one. You can split them over loads and loads of different values. So you can set, for example, if you were doing simply a bit count, it's very fast, but the minute you start doing ANDs and ORs and so on, it becomes an ON operation, the N being how long is your string. So you would want to consider how big do I want that string to be, how long do I want this to take, and then at that point I'm going to start spreading it over different values. For example, just the other day I was running this with around 7 million tweets and it was coming back in milliseconds. But if we got to the stage where it was taking a significant amount of time, then I would start looking at spreading that across different values. Does that make sense? Mm-hmm. So the final part of this is it doesn't really make much sense unless we can get the information out. Now, for those of you who haven't done much work with Clojure, despite being functional, it's and the connotations that people perhaps have about functional languages, it's still got very good support for polymorphism. And one route in particular, you're able to dispatch the different functions based on a predicate. So what I've done with the API onto this is essentially taking a similar approach as MongoDB would do and constructing JSON queries. So you can build up JSON queries that include within it a type of the query that you want to provide, and the value of that, when it comes in through the API and it's gone through your prismatic validation or any of those kind of things, we can actually then dispatch 2 different query type functions based on that value. So you can very easily add in additional files that do different types of counts and automatically just hit your API and it'll dispatch to that specific function and give you back the information that you want, again in JSON. So a very simple web API to front it, again written in Composer. And to be honest, that part itself only comes down to about 20 lines of code. It's very, very small. So from a technical perspective, we could probably end the conversation there. But I think there's still a very important question to be asked, and that's why. We know that there's loads of good motivation for doing this kind of thing, tracking chronic disease being one of them. But there's not always good motivations behind everything in the world. We have to accept that, we have to realise that. Has anybody here in the room ever been involved in any kind of surveillance work? No hands.
Would they say?
Sorry?
Would they say if it had been?
Good question. Does anyone have a social network account of some kind? Twitter, LinkedIn, Facebook? Well, these by very nature are surveillance. And if you're in there and you're looking at any information, then you are involved in surveillance. Now, I'm not saying that social networks in any way are a bad thing. It's got very positive connotations. The spread of chronic disease being tracked is perhaps one of them. But we have to be accepting of what can happen with our data. And especially in this kind of scenario when we're constantly being fed new social networks and new ways for our data to be used, it's very easy for there to be feature creep. It's very easy for the boundaries of what's acceptable, what's not acceptable, to creep. And there's a concept, a German word. Are there any German speakers in the room? Good, so I won't embarrass myself too much. Datensparsamkeit, I believe it's pronounced, which essentially, literally translated, it means data austerity. And the core principle is, if you don't need it, don't collect it. And if you look at the data that we're collecting there in those bitmaps, can anyone think how, from those bitmaps, you would be able to identify an individual?
We have a data and a location, so you could then just look at geography.
Well, we have a location based on country. We have a time frame that never gets more granular than a minute, and we have hundreds of thousands of tweets coming in that period. I always take my heart in my mouth when I ask that question, because I'm always nervous that somebody is going to come up with the answer. But the point is, we've taken care to try and avoid personal information that can be traced back to somebody. Privacy is very important because it's only with privacy, it's only when we feel comfortable within the security of our own homes or our own environments that we've created that we can explore who we are and what we're comfortable with, and then potentially come together and discuss that further and make real changes. But if we're potentially persecuted because somebody's been able to obtain data that shouldn't have been collected, then that's a big problem. Thank you. Are there any questions? Hi.
Yes. With regards to your way of taking a latitude, longitude location and converting it into a nation, is that really the best way of doing it, or was there any kind of, I don't know if you come across geohash, any kind of geohash to geographical location library?
Yeah, there are some libraries.
You would be able to do quite fast with that, I'd have thought. And it just strikes me the way you're doing that as seems wrong, because you're going along and looking and saying, oh, what colour is that? And yes, it works, and it just seems quite a hack to do it that way.
Well, it's certainly a unique usage of the D3 stuff, certainly. Yeah. There are some libraries that do that kind of thing. And maybe you've got better knowledge in those particular libraries than I do, but they tend to come with a database that you have to run, and it tends to then induce network load and so on again. Yeah. One of the big constraints about using that type of LMAX environment, Hadoop environment, is you want things to be in process. You don't want network latency. You don't want big travels across the internet or any of those kind of things. So the big challenge here was, how can we make this run purely in process and not move anywhere? All we want to say is, go that far along, that far down, what colour are you? And that's actually quite fast.
How accurate would you want it? I mean, I get that would give you a fair bit of accuracy. It depends on the image search.
Yeah.
But I mean, for example, I did actually start creating a project that would do exactly this with the geohash system.
Sure.
And the thing I noticed was, and the reason I did it was because I wanted the low latency, I didn't want a database to happen. And I realised if I wanted it really accurate, you would end up needing a database, or you'd need like a large Redis store or something to store possible variations. But if you want it fairly rough, and I mean, when you're getting to sort of the borders area, Carlisle would be in England, but you go 5 miles north of that, and you just you get a slightly sun, and things like that. You go, well, okay, does it really matter? It depends how important that sort of information is to you.
There's certainly always a question about things like aliasing. There's always a question about the data that you've got to construct your map in the first place. There's questions around the size of the map that you're trying to pick things out from. I think all aspects of software, and security and accuracy and speed and so on, comes down to a balancing act. And I think if I look at this and say, what is the worst case scenario that could happen if I'm out by 100 meters? Probably, in the scale of what could go wrong with the incorrect interpretation of the tweet, it's probably pales into insignificance. But it's a very good point, and I think it's certainly something that would be a good topic for further exploration and some further testing. I don't have an exact answer, but I certainly felt quite comfortable with the level of accuracy we could get there.
Good question. What is the level of accuracy?
Let's take that one offline. I've been through quite a few iterations and changes in hashes. I think I'd have to sit down with the code and double check what it was. It's a few months since I did that particular part. Hi.
Do you have a sarcasm factor or something you put into the language training? Because it's only things sarcastic are running. I guess that I would.
Yeah. It's a good question. Certainly, if my daughter looks at me with her big loving eyes and says, "Love you, Daddy," right after stealing some sweets, I probably don't think that's the exact sentiment she's going for. No, we don't inherently build that in. There is a lot of good research out there that looks at those kinds of things. How accurate they get, I don't know. And certainly, from my own perspective here, in fact, this is a good point to progress to the very final slide. The stuff I'm working on is all open source, and I would aim to improve upon it. I'd like to build in much more research work that's being done in there, but at the moment, no, it doesn't accept that. But if you have skills in that area, it would be great for you to contribute.
Of course I do.
Hi.
That's a question more of an announcement, but the first Tuesday of every month there's a Clojure dojo held at Liverpool. The events on meetups, so if people want to get some hands-on experience with Clojure, come on to Liverpool first Tuesday of each month.
Okay, well, I certainly go to the Glasgow Clojure dojo, and it's fantastic, very good learning. So.
There's also the Manchester Wonder Lounge, it's over on next month. So,
Good. Thank you. All right, thank you very much, everyone.